Welcome to this SAP Tech Byte video. This is part 2 in a little series here that looks at the fact that you have an existing HANA database only project and you want to add some service layer enablement on top of it. In the previous video, we started with this premise of the HANA only project, and then we decided to add it or transform it into a cloud application programming model project. And I would still say that that is the recommended approach by SAP, the best approach, particularly if you need OData services. But maybe you want to take your HANA database artifacts and data and expose them in a non-OData way. Maybe you need to convert from express.js. You have an existing project that used the express.js, and in particular, you have non-standard body responses. You're not returning JSON, you're returning something else. You want a webhook or some other communication protocol that isn't supported by OData out of the box. And in these scenarios, you might still be better off using CAP and then using exit handlers in CAP to extend the functionality. But we're going to take the premise that you want to add service enablement to your project and you want to do it completely as pure Node.js. I will say up front, you could probably go online and find some help documents, how to create a REST service in Node.js in 10 lines of code. And yes, I can show you how to create a very simple express handler, put a database, HANA database query in it and return it, and it would be a relatively small amount of lines of code. But you would have a service that would not be scalable, that would not be secure, would not have testing capabilities in it, and things like that. So although we're going to do standalone Node.js, I want to show you how to get very much the equivalent kinds of functionality when it comes to security and robustness that you would get out of the box with the cloud application programming model. Just with the freedom to choose your own format of how you're going to interact, beyond just plain REST or OData that is supported by the cloud application programming model. But I think you're also going to see just how much functionality the cloud application programming model provides for you out of the box that you then don't have to worry about, that in this situation, we're going to have to code ourselves or go find open source modules to do for us. But with that, let's jump into the project at the same starting point that we had in the previous video, which is a pure HANA native project, where we've, designed a few tables and views, calculation views, stored procedures, and we've deployed it to HANA Cloud, but now we want to add service enablement into our project. All right, we're actually going to start here at the exact same point that we did in the previous video. I've got the same starting project, because if you remember in the previous video, we copied it and they made modifications to it. That both kept us safe in case we did something horribly wrong, we could go back to our original project, but also now allows us to easily show you an alternative path that we could take. So just like in the previous project, in previous video, let's start by copying our project. So let me just go up one folder here, and I want to copy the project that I'm in, take my Tech Bytes video, and I'm going to copy it and call this HANA existing Node.js 2, because once again, I've done this once before to test it all out. Do a recursive copy and give that a second to run. There we are. Our project is copied, and now let's reload that into VS Code. Node.js. And once again, just to show you that everything is already deployed to HANA, if I come here to this project, I haven't made any changes to it yet. My computer a chance to reload everything here. There we are. And if we go to the DB module and do an npm start, that will deploy into the HANA database. But just like before, actually, what we'll see is it's going to undeploy a few things because there's probably some stuff from the CAP project version that is no longer in our project that just got removed. But for instance, if I look at the tables that are in our container, here we are, PO header, PO item. If we look at our views, we got basic view, header view, item view. Oh, that source gen. Just because I copied from what we had there before, I probably brought over. No, it didn't undeploy that, but that's okay. That's not going to cause us any problems. Just you wouldn't, if you were starting real clean, unlike me, and not having done the other part, you might not see these other three views, but they're not going to affect anything we're going to do here. So I'll just leave them for now. Now, we need to adjust our project structure because right now we have one folder with a DB, and if we look at our mta.yaml, it's got one module looking at the DB. There's no wizard like we had with the cloud application programming model where we use the CDS init and CDS add that will add additional modules to our project. We're going to have to do this a little by hand, but it's really not that complicated. For instance, I'll just go ahead and create a folder in the root called SRV for our service layer. And then I'll come here and create that module. In fact, I can pretty much just cut and paste the DB module. And let's define an SRV module. SRV. Now the type is going to be different. It's going to be a Node.js type. The path is going to be SRV. It's still going to require the HANA PO for its connection to the database. But then the only other thing we need to require, if we want to put the application router on here as well, which we're not going to do in this video, but it's likely that you might want that, particularly to set up a UAA for security. So to do that, we'll just add the provides, and then provides name, SRV API, properties, SRV URL, and default URL. So we're just exposing our URL dynamically via this variable SRV API, so the app router can use that later. Totally optional. We could have left that part off. It isn't going to hurt anything for our case. Now, what we want to do, we've got this SRV module. So I'm just going to change directory. Yeah, oops, if I back up. So now I'll change directory into SRV. There we are. Nothing currently in this folder. Yep, empty. So what we can do is we can use npm and say npm init, and it will initialize this folder for being a Node.js module. So we'll just keep the default version, description. I don't even have to add that. Let's see. I want to keep I want to make sure I'm consistent with my example. Yep. Index.js. Don't need a test command. Don't need a git repository. Just pretty much say yes, that's good. And all that really did is create a package JSON for us. And doesn't really add too much here. But it's going to start with an index.js, which it didn't even create for us. We're going to have to create that manually. So we'll just come here and say index.js. So although there's not a wizard to do this initialization for us beyond the npm init, it's not like you really need too much support. It's kind of all laid out pretty easily for you. But what we are going to need is we're going to need a bunch of Node.js modules that are going to be dependencies. So I'm going to go ahead and grab those from my finished project. Now, I did this the other day. I added these one at a time as I needed them. In hindsight, I can add them all up front, and then I just don't have the back and forth of having to do an npm install as I go and use them. But what you're seeing here is I need quite a few in order to get the functionality that the Cloud Application Programming Model provides me. I need several different SAP modules that are used internally inside the Cloud Application Programming Model, to handle security and language translation, logging. If I was using the Cloud Application Programming Model, like I said, all that functionality is bundled into the CDS module. Likewise, I'm going to need equivalent functionality to do things like handle security. I've got Helmet here to do monitoring, to handle, to be my web server. That's going to be Express. To be able to do health checks and tracing on my application. Once again, these are things that primarily the Cloud Application Programming Model has built in. Now we've got to go get pieces and parts from elsewhere. But this is the selection of modules. I mean, there's no right or wrong there, but this is what I happen to use, pulled from different places. Now, of course, once you have this in the SRV folder, you can run an npm install, and it will bring down all these modules. And because we have a fair number of modules listed there, this is going to take a minute or so to bring everything down from npm. So I'll pause the video and pick up when after it's finished. All right, so let's start into the coding. We're going to have to code a lot of stuff ourselves. I want to start here in the index.js. And I'm going to keep this very simple. I want my entry point here to be really clean. And I'm going to put most of the processing of initializing Express being a very common module used in Node.js to provide the web server, basically, for our service. And actually, the Cloud Application Programming Model uses Express internally as well. So we haven't deviated much from what we would get with the Cloud Application Programming Model. But we just want to initialize Express, and actually decided to put that in a separate file, just to keep things clean here. So we're going to create this expres-server.js as a separate file. So let me go there, get my logic, let's bring it in and have a look at it. A little too much for my sample. There we are. Not going to go through every line of code here, because you can certainly look in GitHub. I've posted all the sample code, and I'll put the link in the description of the video, taking you exactly to where you can find this in the SAP samples repository. And of course, you can study the code at your own pace. But basically, what we're doing here is we're initializing Express. And two things that I want to do. I want to make this very easy to add additional routes into Express. So I've got this little bit of dynamic logic here that will look into a folder called routes, and will look for any file that has a .js, JavaScript extension, and it will load it dynamically as a route handler. And that way I don't need a little library or script or anything that's going to state what my routes are. Just by putting any JS file in this routes folder, it will automatically be a route. And a route is just something that handles a particular URL, right? So just like with our OData, we saw certain paths, and each entity then is part of that path. We can build that ourselves and decide exactly what we want that structure to be, simply by adding files to this routes folder. Now, I haven't created the folder yet, but that's okay. The other thing that we wanted to do here is we want to do some further initialization on the server side to do more of the Express configuration. All we've done is really initialized Express as a web server, started it up, and then we're going to push like all the security setup and the connection to HANA and stuff like that. We're going to put that in a separate file as well, just to keep our logic flow real clean here. So let's go to the server folder. Let's create that. Server. And now create a file in here called we're just going to start with an express.js. And if we look at the logic here, what do we want? So what we want to do is, I'm not really using this body parser anymore. Am I? Let me take that out. We want the web server to use certain things automatically called middleware, little plugins into the web server. And we can take things like the SAP logging library and connect it to Express as a middleware, even though it's an SAP supplied module. Many of them are designed to run inside of Express. Once again, this is something that the cloud application programming model would do automatically for us, but we're having to do it ourselves since we're writing this all from scratch. Just like we did in the cloud application programming model, we used the Open API specification and the SwaggerUI test tool. So we're going to add that into our standalone service as well. I'm just going to put that processing in a separate file called Swagger. I need to load the environment. I'm going to use the SAP supplied module XSENV to do that. And I'm going to connect to the HANA database and set that HANA database connection as middleware into Express as well. And then it will handle the connection pooling for us and hand us back a connection to the HANA database every time we have a HTTP request. Once again, cloud application programming model would be doing these sort of things for us. I'm adding a health check and overload protection, core security, and other express security as well. So I'll tell you what I'm going to do. Rather than cut and paste all these files while you watch, I'm going to pause the video. I'm going to set up these additional files, and then we'll walk through what each of them does. All right, so we want to look at the implementation now for all these different parts that we've hooked in here to our Express server initialization. The first one is Express Security, which we're loading here from the Express initialization. And what we see here is we're setting up the security settings and requirements. We're using a module named Helmet to be able to set the content security policy that sets certain headers that will tell the browser where the servers can be called from and what referrers there can be. We also load Passport and the XS security module. These are, if you are running behind an application router and want to use a UAA, User Authentication Authorization Service instance to secure your service, just as you would do with the cloud application programming model, you could uncomment this section and then it would require a UAA instance and do validation against that and make sure that that is your authorization and authentication. For testing purposes, we'll go ahead and leave this commented out and not apply any security to our service for now. Or authentication, I should say. We won't apply any authentication to our service. Next, we have health check. Health check is performed here during initialization, and we're going to pass in our connection to the HANA database as well. This health check is something that can be called automated by either Cloud Foundry or Kubernetes, depending on where our service is deployed, and allows the controller or other monitoring frameworks to basically ping our service and see if they're healthy. And inside here, we can do checks that we want to respond to see if our service is healthy. We're going to do two very simple ones. We're going to check the event loop and see if there's any lag responding to the event processor in Node.js itself. Like if we were under load, like there was too many requests coming into the service, then this lag would increase. If we see the lag more than 1,000 milliseconds, then we want to return that our service is not healthy. The other thing we want to do here is just create a connection to the database. And if we are able to connect to the HANA database that we have configured for our service, then we're going to assume that it's good. Now you could do more complicated things. You know, you could actually try to read from a table or look at, system parameters, but we're going to keep this very, very simple with this initial health check. Next, we have overload protection. This is basically if we have too many requests coming in, we don't want our service to just get bogged down. We want to put a circuit breaker in place so that it cuts off the request and doesn't try to process them, and instead returns an error immediately. And that protects our backend, like the HANA backend database, from being overloaded with too many requests in say, a denial of service attack or something like that. So we're just using an open source module, overload protection, and this is the configuration of that module. And we're hooking it into our instance of Express, and it does the rest of the work. And then finally, we want SwaggerUI. If you watched the previous video, you saw that we used Open API and SwaggerUI to do testing of our service. And we're going to put the same functionality in here. It's going to read JSDoc documentation in our route handlers and turn that into the definition, our Open API definition automatically that the SwaggerUI can use. And we'll see this in a minute once we create some routes. We don't actually have any routes yet. The only route handler I have here is to expose the SwaggerUI itself. So we've got a basic service. We actually have enough here. We could come and do an npm start and test this. So it's starting up. And I can go ahead and launch it in my web browser. We have nothing at the root because we haven't set up any root handler. But for instance, if I come here to the health check, we'll see that, yes, the service is up. The event loop lag is up. Nothing's wrong with it. If there had been an error, it would show it there. And that the HANA check also passed. It's up. So no errors. So we're able to connect to the HANA database, and we're processing in a reasonable amount of time. And, you know, this health check is an endpoint that could be ran periodically, like I said, by some administrative framework surrounding our service. Like maybe it checks every minute or every 10 minutes or whatever, just to make sure our service is healthy. Otherwise, it can throw an alert. Now, about the only other thing that's built into our service is we could go to API docs, and that will load the SwaggerUI, but we don't have anything in it yet. We haven't created any services. We don't have any RESTful endpoints. We've just got our framework of our service. So in the next step, we want to add a route that actually exposes certain HTTP endpoints as services, and very similar to what the Cloud Application Programming Model does, it creates RESTful services, so using put, post, get, for the different operations. We're going to do the same thing, but we're going to hand code those, unlike letting the generic handler of the Cloud Application Programming Model do it for us. So once again, I'm going to pause the video. I'm going to put the code in so you don't have to watch me type it or cut and paste, and then we'll walk through it and see what it's doing. Okay, for this last part, I have created another route in the routes folder. Remember, any JS file in this folder named routes is automatically going to be loaded by Express for HTTP endpoint route handling. And I say automatically, and it's not happening automatically because of something Express does or because there's the name of that certain folder. It's all here in this coding. Actually, this little block of code here that says load routes, it's looking for files dynamically in a certain folder and then adding them to Express. So nothing sort of magical happening there. But what we want to do, we'll come back to this in a second. We want to create routes, and here we're putting the URL path. So we're going to say at /POS or purchase orders. When we get an HTTP GET request, then call this list all POs, which this is just a separate file here to put the logic over in a separate file, which we'll look at in a second. And when there's a post operation, then call the create. And then we want to create another route also with POS, but with an input parameter to take the purchase order unique ID on the URL. And when we get that, when we get a GET request, we do a read of a single purchase order and a put to update or a delete operation to delete. Okay? Now, the implementation of these is pretty simple, and I only implemented 2 of them to show you the 2 different situations here. You could implement the other CRUD operations if you needed them, but the list all purchase orders we get the request and the response object. The request object automatically has this .db. This is our HANA database connection that was supplied by the SAP middleware being added to Express. Once again, Cloud Application Programming Model handles all this for you. When the request comes in, it automatically gets the connection to the database and stuff like that. Here, we need to go ask the request object for it, but then we can just issue SQL statements. So in this case, select star from PO header, limit 10, and return the results. And we're going to have a very simple REST handler, but unlike the Cloud Application Programming Model, we don't have filter, we don't have order by, we don't have limit as URL parameters. It would require a lot more manual coding to set up all the input parameters and the dynamic processing, the query and stuff like that. So once again, Cloud Application Programming Model does a heck of a lot of work for you. And I would only take this approach if you absolutely need more control over the response body or the processing that's going on here. Actually, for the simple process of what we're doing here, of just selecting and returning JSON, I'd be just as well off using the Cloud Application Programming Model. I'd be better well off, I would say. It would be much simpler. But I'm just showing you how to create this corresponding thing. If then from here, if you had specialized requirements, that's why you would break into this approach, but that then would depend upon your specialized requirements, wouldn't it? Likewise here, to read a single PO, we have an input parameter on this one. That's why it's different, PO ID, and it would be passed into the request object params. We can get any input parameters we define via the URL there, and just going to connect to the database, write our SQL statement query. Only this time we need to pass the input parameter into the query. We'll get the results back as JSON once again, and we can feed those into the output. And we've got two RESTful services that run on top of HANA now. Now, the only other thing we want to do is we need this JSDoc. This is a documentation block, so it's not doing anything except the SwaggerUI is going to use this to build our test page dynamically. Once again, the Cloud Application Programming Model, we have our ability to say compile to OpenAPI, and it generates this dynamically for us. Here we have to code it ourselves, so we basically have to define the service interface. What are the parameters? What are the output, input? What kind of errors can I expect? Otherwise, the test tool doesn't know what to give you to test the service. Now, the hardest part of this is probably putting the schema for the JSON that we expect to return or take input in the case of the create, is we have to define the data types and everything. Now, this is where we can say, for instance, let's just say HANA CLI views. Which view are we using here? I think this is our PO basic view. And, this is PO header view. And if we want, just like we used the inspect view and told it to generate CDS, and that's how we were able to create our proxy objects, we can do something similar here where we can say HANA CLI, inspect view, output, open API, and then give it our database view name. And what it's going to do, it's going to use that similar CDS. That's interesting. It's not a function. Very interesting. Why that gave me that error. Let's try this right here. SWGR. There we are. And what you're seeing here is basically the information that you need, although in a slightly different format. That's why I was going to use the other command, and I'm not sure why I got that compile to error. I'll have to look into that. That shouldn't happen. But I'm using the Cloud Application Programming Model internally inside the HANA CLI to do the same sort of dynamic conversion from the database schema definition, in this case, to Swagger, which isn't quite, it's the same information you see here, integer, int 32, and it's giving my my types correctly, but the format isn't exactly the way that I use to put into this schema, because this is actually Open API. Like I said, I need to see why that that other command didn't work for me in this instance. It worked earlier. Actually, here we have most of our same information here, just a slightly different format, right? But you see, this can help you build this schema. But this is all sort of optional. If you didn't want to use the Swagger test tool, this isn't needed to create the REST service. It's just very helpful in this tool that's going to allow us to test the REST service. But enough for the walkthrough. Let's go ahead and do an npm start so we can run our service again. And this time, what you're going to see is that when I go to the API docs, is now we have a schema defined for our POs. That's all coming from this document block. And we have our purchase orders, and we have our 2 implemented service handlers /POs. And we can test it from here as well. We do an execute. And there's our purchase order. We see the JSON body coming back. See the headers. We can test the PO ID. This is where Swagger is really nice. It takes that as an input parameter and it'll validate it as well and make sure that we haven't messed up the data types. Yeah, see, like it shook there and told me, no, you can't do that. You violated the integer type. Then we execute that and we get a single record back. So we know our 2 route handlers are working. And we could test those via just URL because these are just get operations. Of course, if you had put or post delete operations, those are much harder to test. Impossible to test from the browser alone. And that's where a tool like the SwaggerUI is very helpful. But what we see here is we have implemented a RESTful endpoint that returns JSON, very similar, well, identical to the output that we would have got using the REST handler and using the Cloud Application Programming Model. But we have a lot more code that we had to do ourselves. We're responsible for all the security, the route handling, the query generation, all that. We don't have nearly as much service functionality as far as filtering and order by and stuff like that. You'd have to add all that yourself, or find a helper library to generate all those additional options. So once again, if you're creating RESTful CRUD services, just use the Cloud Application Programming Model. But if you truly wanted something unique, which we didn't do here, but creating WebSockets, webhook, you want to return a response body that, say, is a binary zip or something like that, or Excel format or something of the like, then the approach that we've taken here, just with different handler implementations, would give you the freedom that you would not necessarily have with the Cloud Application Programming Model. So with that, we've shown you 2 different approaches in which you could take your HANA database only project and add different types of service enablement. In the first video, we showed you how you would use the Cloud Application Programming Model. That would be the recommended approach in nearly all cases. And in this video, we've shown you how you can build your own Node.js module and custom code your own route handlers, which of course means taking on more responsibility to code security and robustness and everything into it. But hopefully we've shown you a bit how to do that. And if nothing else, proven to you just how much value there is in the Cloud Application Programming Model doing a lot of this work for you.